this video, we're going to work through an electrical potential problem. So it's a fairly complex problem, this one. So we're going to consider the diagram opposite. We've got charge here of minus 6.5 microcoulombs and a charge here of plus 8.3 microcoulombs, and they're 10 centimeters apart. And basically what we're going to do is we're going to explore the potential between these. So if these charges are separated by a distance of 10 centimeters, we're going to find the potential at the midpoint between their centers. So the midpoint, you can see, is going to be 0.05 meters. Now, the first thing that we need to know is that this is a vector problem. And the reason why it's a vector problem is we've got a negative charge for A and a positive charge for B. So I'm going to write that down. Okay, so I know that basically each charge has a potential at 0.05 from the center of each of the charges. So let's work out the potentials for each. Let's work out the potential for QA. Now I know it's negative 6.5 microcoulombs acting 0.05 meters away. So what we know as an equation is E, the electric field strength, equals the voltage over the distance. But we don't know E. But however, we do know that E can be calculated using K, which is our constant, times QA times the distance squared. And if we substitute E into the first equation, we can then have an algorithm for V which doesn't involve E. So I get K times QA over D squared equals V over D. Now if I move the D up and take it to the other side to make V the subject, I get the two D's can cancel out, so I get the V equals Q times QA all over the distance. I know that K is basically 9 times 10 to the 9. I know QA from my equation, from my question, is minus 6.5 times 10 to the negative 6 coulombs. I've just converted with that microcoulombs, and I know that D is 0.05 meters. So VA will be 9 times 10 to the 9 times negative 6.5 times 10 to the negative 6, and that D is 0.5, which gives me a voltage of negative 1.2 times 10 to the 6 volts. Now what we'll do is we'll look at the same potential for QB, or charge B. So I use the same algorithm, so I know what K is, I know what the charge of B is. It's positive 8.3 microcoulombs, or 8.3 times 10 to the negative 6 coulombs, and I know my distance is going to be 0.05. So substituting them into the algorithm for VB, I now can then calculate it as 9 times 10 to the 9 times positive 8.3 times 10 to the negative 6, all divided by 0.05 meters, which equals 1.5 times 10 to the 6 volts. Now, what else do I know? Well, I've got the two voltages at this point. Now I need to combine them. As they're both going in the same direction, and that's basically because I've got a negative charge for A, which means that the electric field lines are going into it, and for B, they're going away because it's positive, I can add the two algorithms. So I'll just note that down. That means that my total potential at midpoint is VA plus VB. Now I know that VA is 1.2 times 10 to the 6, and I know that B is 1.5 times 10 to the 6, but I know that A is negative, so I've got to substitute that in. That gives me 0.3 times 10 to the 6 volts. It's my final answer. Thanks for watching.